welcome to this session of Class 9 Mathematics, and I am your Anu again. This is a new chapter today and it is Triangle Chapter 7. So in this chapter we are going to see about triangles in details. Actually we have seen geometry, introduction to Euclid's geometry, then we have come to lines and angles, and then we are slowly moving to triangles chapter. Okay, so what do we mean by triangles? We know triangles are three-sided figures, and those three sides are made up of line segments. So it's just a simple closed figure formed by three intersecting line segments, isn't it? Lines has to intersect to have a common meeting point at the three ends. Okay, so there's another thing to be pointed out in this point is triangle is made or formed by three intersecting line segment. So the other way we can define triangle is if there are three non-collinear points, that is points which do not lie on the same line, three non-collinear points, then we can join those three non-collinear points and it forms a triangle. See, some three non-collinear points, they don't lie on the same line. Collinear points lie on the same line, isn't it? So three non-collinear points and we join them to form a triangle. So a simple closed curve with minimum points, that is with 3 points, is a triangle. Okay, it is made up of line segments intersecting each other at 3 points. So what are these 3 points called? Meeting ends of the line segments called? They are called vertices. A, B and C are called vertices. Singular is vertex. So A is a vertex, B is a vertex and C is vertex, and these are vertices of the triangle. That is the end points of the line segments. The line segments, that is AB, BC and AC, these line segments are called sides of the triangles. So these concepts you have, we have studied earlier, but this is just a recap for us. So AB, BC and AC are sides of the triangles, which are line segments, and these line segments meet at a point. Okay, the line segments AB and BC meet at a point, and where they meet they form an angle between them. Because they are inclined to each other, they form an angle between them. Likewise, you have an angle here and angle here. See, they are just called angle A, angle B or angle C and angle C. Or they can also be written as, see, this angle A can be written as angle BAC. Note down, see, A, if the angle A has to be written, see, that A, letter A comes in the middle. So BAC. So where the angle is enclosed, the vertex has to appear in the middle. So it can also be written like this, and angle B can be written as ABC. And angle C can be written as angle ACB, or simply as angle A, angle B and angle C. So we have seen sides, vertices and angles of the triangle. Now let us see what are the types of triangles. Before going into types of the triangles, we'll see what are the angles inside, that is interior, in the interior region of the triangle. Say they can be acute, and one of the angles can be obtuse, and one of the angles can be right angle also. All the three angles can be acute also. Okay, so obtuse can be only one, because one obtuse angle, the other two will be acute. So that is what I am trying to say, that is I am coming to say we have the sum of all angles. Angle A plus angle B plus angle C should always be equal to 180 degree. It should not be less than that, or it should not be greater than. It should be equal to 180 degrees. Only then a triangle can be formed. So what is this? A plus B plus C, that is angles A plus B plus C is equal to 180 degree. The sum of all angles in a triangle should be equal to 180 degrees. So if one is an obtuse angle, the other two angles have to be acute angles. Okay. Likewise, if one is 90 degree, the other two angles will be acute angle. Or all the angles can also be acute angles, so such that the sum of all the angles should always be equal to 180 degrees. So whenever you're given with angles, you just add them up and see whether they come up to 180 degrees. The sum comes to 180 degrees. If at all you have 180 degrees, then you can form a triangle with that. If it is less than 180 or more than 180, you will not be able to form a triangle. So this property where the sum of all angles is equal to 180 is called the angle sum property. ASP, angle sum property. Okay, so this is very important for the construction of triangles or to understand the triangles. This angle sum property is very important. So note it down. The sum of all angles in a triangle should always be equal to 180 degrees. This is very important. Okay. So next, now we will come to the types of triangles. So we have types of triangles on the basis of, we have defined sides and angles, isn't it? So on the basis of sides and angles, the triangles are classified into many types. So according to sides, let's see what are the types of triangles based on sides of the triangles. So sides of the triangle, see, if you have a triangle like this, let it be this, the side, that is the length of one side may be 5 centimeters and this be 8 centimeters and this be 6 centimeters. If all these sides are of different lengths, that is the sides are not same or not equal when they are different, then that type of triangle is called a scalene triangle. What is it called? It's called a scalene triangle. So scalene triangle has all the sides, they are different. The sides are different. They have different sides. So scalene triangle where the sides are not equal. So if it is not equal, then there should be a triangle where the sides are equal, isn't it? So when all the sides are equal, see, when all the sides are equal, then this type of triangle is called an equilateral triangle. What is it called? It's called an equilateral triangle. Equilateral, equal sides. So equilateral triangle where all the sides are equal. Then you have both the sides to be equal, that is two sides to be equal and one is different. So when two sides are equal, we call it as isosceles triangle. Iso means same, so two sides same, two sides equal. That type of triangle is called isosceles triangle. So we have classified triangles on the basis of the sides of the triangle. So where the sides are different, we say scalene. The sides are not equal in length. Each side has a different length. Then we say it's a scalene triangle. When all the sides are equal, the length is the same, then we say it's an equilateral triangle. When only two sides are equal, the length of two sides equal and the third side is different, then we say it's an isosceles triangle. Okay, so this is according to sides of the triangle. Now we'll get into angles. We'll see what are the type of triangles we have depending upon the angles, different types of angles. In the beginning I told you that triangles, the angles in a triangle can be either acute angle or obtuse angle, or even it can have a right angle too, isn't it? So when we have all the triangles to be acute, okay, when all the triangles to be acute, say it will be like this, when all the angles in the triangle to be acute angle, then that type of triangle is called acute angled triangle. Okay, so this is first time when all the angles are acute. Okay, it is possible because acute angles are always less than 90 degrees, so all the angles can be acute. So acute angled triangle which has all the angles as acute angles. Next is when one of the angle is obtuse, that is more than 90 degrees. When one of the angle in a triangle is more than 90 degree, that is one of the angle is obtuse, then that type of triangle is called obtuse angled triangle. Okay, so this is obtuse angle triangle when one of the angle is obtuse. Now the next one is when one of the angle is a right angle, that is 90 degrees. When one of the angle is 90 degrees, then we call it as right angle triangle. Okay, and the fourth one is, we have another one, that is fourth one, when all the angles are equal. When all the angles are equal, just like when all the sides are equal, here all the angles are equal, then it is called an equilateral triangle. See, this equilateral and this equilateral triangle are one and the same. I'll explain you how it is. See, we have seen acute angled, obtuse angled, triangle, right angled, and now this is equilateral triangle. See, you have a relationship between the side and the angle. These are the angles, and AB, BC and AC are the sides of the triangle. So when you have all the sides equal, okay, when all the sides are equal, the AB is equal to BC is equal to CA, and then we also have angle A is equal to angle B is equal to angle C. That is, see, when these two sides are equal, then these angle opposite to this side, that is angle opposite to AB is C, and the angle opposite to AC is B. See, just opposite, these two angles are equal, and if all the three sides are equal, the angles opposite to those sides are equal. Okay, do you understand? So the angles opposite to equal sides are always equal, so that you should understand. So that is how, if all the three sides are equal, then the angles opposite to them are also equal. So naturally all the three angles are also equal. So equilateral triangle means all the sides are equal and all the angles are also equal. So now we have seen types of triangles depending upon the sides and the angles of triangle, and we have also seen the angle sum property, that is, sum of all angles in a triangle should be equal to 180 degree. This is an important concept. Now, after seeing the types of triangles and after understanding the sides and angles of the triangles, now let's see the angle sum property, that is angle A plus angle B plus angle C is equal to 180 degree. So let's see how this happens. Let us take triangle. This is A, B and C. Okay. So now to prove that the sum of all angles is equal to 180 degree. Now let's draw. See, BC is a line segment, one of the sides of the triangle. So let us draw a line parallel to BC. See, this line is, the line through A is parallel to BC. So let us name the line as L. So we have L is parallel to BC. Okay, the line L is parallel to BC. Now this is 1. We take this as 1. This is 2 and this is 3. So let us assume the angle to be 1, 2 and 3 for ABC respectively. Now we have drawn a line parallel to BC, okay, through A. Now what happens is, we have already done in lines and angles, that is when there are two lines parallel to each other, and when we draw a line, falling line, that is transversal. Okay, it intersects the parallel lines at 2 points, and we have also you know what are all the angles made by the transversal with the parallel lines. See, these two angles, that is angle 1 and angle 2, are alternate interior angles, they are equal. See likewise 3 and 4, angle 1 is equal to angle 2, angle 3 is equal to angle 4. So these are alternate interior angles. So these are equal. See 1 is equal to 2 and 3 is equal to 4 because alternate interior angles are equal. So we know that. And angle 4 and angle 5 are equal because they are corresponding angles. Likewise angle 2 and angle 6 are equal because they are corresponding angles. So we know that, isn't it? So this was just to recollect. Okay, so that is what we are going to apply here. See, these two are parallel lines and I extend the line AC with a dotted line and I extend this line also AB with dotted lines. So just to imagine that these two are parallel lines and this is a transversal. Okay, so these two are parallel lines now and this is a transversal. Now let's see what happens. What is this 3 now? See, you have BC here, this is BC and this is the line L and AC you have here. See, this is A and this is C, isn't it? So this is C. Now where is 3? Here, angle 3 is here and I am asking you about this angle. See this angle. Okay, so what is this angle? See, able to understand, I think, the diagram. I have just recreated the diagram here in terms of two parallel lines and the transversal. Now AC is the transversal here, intersecting the parallel lines at 2 points A and C. Now this is angle C I have drawn here. I am asking about this angle. See, what is this angle now? So this is alternate interior angle. See, alternate interior angle, and hence see alternate interior angles, you have these two angles to be equal, isn't it? Alternate interior angles are equal, therefore this 3 is equal to 3 here. Okay, so I put 3 here because this is equal. These two are equal, one and the same, so I write 3 here. Okay, now what do I do is I am concerned with this angle now. So what about this angle? So let me draw the line for this angle. So you have BC here and the line L here and AB. I draw AB here. See, you have 2 here. Okay, so 2 here. And what about this angle? So this angle, because this is the line I have extended. What about this angle? See, what is this? It is just the 2 because this is also interior opposite angles, isn't it? So interior means within the parallel lines, inside the parallel lines, and the angles made by the transversal interior alternate angles, they are one and the same. So I have written 2 here. Now do you understand? So that is what I have recreated here. So now you will be able to understand that this 3 and this 3 are one and the same, they are equal, and this 2 and this 2 are same. These two angles are same because they are interior opposite angles, because I have taken this L and BC to be parallel to each other. Okay, now what can you say about this 1 plus 2 plus 3? Since this is a straight line, now can you find out what is 1 plus 2 plus 3? Yes, the angle in a straight line. Yes, very good. So the angle in a straight line, 2 plus 1 plus 3 is nothing but, see, it is like this, 2 here, 1 here and 3. So it is just separated by lines, but this is 1, 2 and 3. So when we add all the angles, angle 1 plus angle 2 plus angle 3, it comes to, so what is the angle in a straight line? It is 180 degrees, isn't it? So 1 plus 2 plus 3 becomes 180 degrees. So that is how we say angle 1 plus angle 2 plus angle 3 inside the triangle as 180 degrees. So that is what angle sum property states, that sum of all angles in a triangle is equal to 180 degrees. So that is how we prove sum of all angles in a triangle is 180 degrees. Now do you understand? Yes. Now we have seen the interior angles of the triangle, isn't it? We have seen the interior angles, that is the angles formed by the line segments in the interior region. So they are called interior angles. So these angles A, B, C are called the interior angles. Now let's see some more angles. That is, when I extend this BC, I extend the line BC here, I extend the line AC, and I extend the line AB. Okay, so if I extend the line AC here, see, I have an angle formed here. Okay, likewise I have an angle formed here and I have another angle formed here. You understand? Okay. So what can you say about these angles? See, what can you say about these angles? These are exterior angles. What are they? These are exterior angles. Why they are called exterior angles? Because they lie on the exterior region of the triangle. They are not in the interior region, they are in the exterior region of the triangle. Okay, so that is what we call exterior angles. Then what can you say about the angles with respect to the interior angles? See, these are interior angles and the exterior angle. What can you say about the interior angle and exterior angle in a at your point or at a particular vertex? That is, see, can you see this is a straight line and these two angles form a linear pair, isn't it? Because since they are in a straight line, they add up to 180 degrees. So the interior angle at a vertex, the interior angle and the exterior angle form a linear pair and they add up to 180 degrees. Okay, or they can also be said the angles are supplementary to each other. That is, they both the sum of both interior angle and the exterior angle at a vertex is 180 degrees. See, you can see, or the exterior and the interior angles, the sum will be 180 degrees. They form a linear pair. So that you should understand. And also the other thing is, see, let us take this to be 1, this to be 2 and this to be 3. 3 exterior angles. So the other thing you should know about this is the other fact you should know about the exterior angle is angle 1 is equal to, see, this exterior angle, angle 1 is equal to sum of the opposite interior angles, angle B plus angle C. So angle 1 is equal to angle B plus angle C. Do you understand? So this is actually, this is, if this angle is 1, what is this? This is 180 minus 1, isn't it? 180 minus 1 is this. Okay. So what is 180 minus this angle? That is the sum of two angles, because we know the angle sum property, all the three angles should be equal to 180 degrees. So when you subtract this angle from this, you will get the rest of the angles, sum of rest of the angles. Okay, B plus C. So that is what. So angle 2, that is this exterior angle, will be sum of the opposite interior angles. Likewise, angle 3 is equal to sum of the opposite interior angles. That you should understand. Interior here 1, 2, 3 means exterior angles and A, B, C are the interior angles. Okay, so this you should understand. This is the exterior angle property. It states that the exterior angle is equal to the sum of the two opposite interior angles. Okay, so that you should remember, keep in mind. So when we move on to problems, we'll apply these theorems, the angle sum property, these properties, angle sum property and the exterior angle property, whenever it is required appropriately. Okay, so now we have seen exterior angles, interior angles, angle sum property, and next important concept in the chapter is the concept of congruence. So what do you mean by congruence? Congruency is a property where, I mean, in figures or in line segments or angles or circles or squares in figures in general, if they have the same size and shape, so that one figure is superimposed on the other, it covers exactly the, it covers the previous one. When you superimpose one figure over the other, then it covers the previous one, the whatever skipped previously, it covers it exactly. It sits on it exactly and it covers it. Okay, so that is what we call congruency, which are same in size as well as shape. That is called congruency. And depending on the whatever shape it is, that is line segments or angles or circles or squares, we have the concept of congruence in each case. So the congruency symbol is written like this. When I say a line segment AB is congruent to CD, AB is congruent to CD. When I say, I mean that the length of AB is equal to length of CD. Okay, so AB is equal to CD. That is, the length of AB is equal to CD. Then I say those two line segments are congruent to each other. Next, when I say angles, see, if I say ABC is an angle and PQR is an angle, so I represent angle ABC is congruent to angle PQR, which means angle B is equal to angle Q. Do you understand? So the angle, the measure of angle is equal. So I say the angles are congruent. Now going on to the circles, see, we say if we have a circle here with center O1 and this is the radius, this is circle 1, and this circle is congruent to another circle C2. If I say these two are congruent, then what I mean is the radius of both the circles are equal. See, R, it is R. The circles are different with different centers, but the radius is same, so they are equal. Hence, the circle 1 and circle 2 are congruent to each other. Now, next thing, when I take square, if I say this square is congruent to ABCD is congruent to another square PQRS, this is congruent to PQRS, then what do I mean is all the sides of the squares, both the squares, the corresponding sides are same or equal. What do you mean by corresponding side? AB is equal to PQ and BC is equal to QR, RS is equal to CD and DA is equal to SP. That is, the sides of the squares are equal. Okay, so one thing I want to stress here is for the shapes, see, for circles and squares, the concept of congruency goes beyond the length of the line segment, length of the sides or the length of the radius. That is, the area will be equal. If the squares or the circles or any other figure or any other shape, if they are congruent, then the area will be equal. Just like the sides equal, the area will be equal. But the converse, that is, when the areas are equal for two figures, then they are congruent is not true. They may or may not be congruent, because if I say a circle has an area of 10 centimeters square and a triangle which is also having an area of 10 centimeters squared, so the area is same but the shape is entirely different, so it is not congruent, isn't it? So we can't say if the area is equal, then the figures, the shapes are congruent. The only thing we can say is if the shapes are congruent, then the areas are definitely equal. Okay, so that is the thing you need to remember about congruency, and that is what I want to say about congruency and area. Okay, that you should remember in mind. So whenever I say two shapes are congruent, then the sides or length of the sides are equal. If it is a circle, the radii are equal for both the circles. The circles which are congruent to each other. And if at all there are line segments, then the length of the line segments are equal. And if the angles are congruent, the angles are equal. Okay. So when the two shapes are congruent, then the areas are also equal. But if the areas are equal, They may or may not be congruent. Just like in this case, square and triangle, they have they have equal areas, but they are not congruent because they are entirely different shapes. So only we can say the shapes are, the figures are congruent only when they have same shape and same size. So this is about congruency. We'll see congruency in triangles in detail in the next class. So until then, keep practicing the concepts we have done here, keep revising the concepts. Until then, it's bye from Anu. Let's meet again in the next class. Thank you.